we'll be looking into the second use case that Tony has touched upon, empowering the application servers, and just a quick recap on the dimensions that that we mentioned before. What people deploying database applications in the cloud care about. Of course, they care about data protection, and this entails increased database uptime. Of course, they care about performance, translating to application and database scaling. With the Pliops card, we're actually speaking about the vertical scaling within every single server, so that we can make better use of its compute resources. Capacity, of course, which drives cost. So people would like to use lower cost TLCs or QLCs, but with no performance penalty. And at the end of the day, vertical scalability and performance are linked to efficiency, because doing more on an accelerator card allows us to consolidate databases, run more database instances per server, and at the end of the day, reduce the infrastructure footprint. So let's take a look at another example of a database service provider. Actually, this is a superscaler customer that provides SQL database service as a service, and their current solution entails triples of servers, each deployed with two SSDs with in non-reliable RAID 0 mode. So overall, this whole configuration can host 15 database instances with 41 usable terabytes of data, and RAID 0 configuration, as I said. In their environment, this translates about 600 failures per year, mainly driven by storage failures, as Tony mentioned before. So with Pliops, they are able to transition to a much denser configuration with just one server packed with 8 SSDs, and there we go to 20 database instances with 66 terabyte usable, and you get the internal drive failure protection for free, provided by Pliops. So as we make the math, as you see, you can actually go down about 50% in cost, 33% increase in the number of database servers you can accommodate within this bare metal machine, 66% more capacity, and the drive-related failures, we actually draw them down to 0, because thanks to this built-in drive failure protection. So let's see.
Edward, you went from 15 terabyte SSDs, 6 of them, to 8 terabyte SSDs kind of thing. Did you guys do that because you needed that for the parity support, or why didn't you stick with the same 6F15 or 15 terabyte SSDs?
So I guess, Tony, this was the customer choice in this case. Yeah,
that's, we followed exactly what they asked.
Yeah. This wasn't a requirement of your
no,
data protection.
It's not a limitation. Actually, we can actually see in the SQL an example how we go to a higher capacity QLC drive from that exhibits better performance than medium capacity TLC drive at a lower cost.
And the 600 failures per year, those were SSD failures, or those were?
There were server failures or data service interruptions that were incurred by SSD failures.
And there's a single Pliops card in the solution.
In the server, yes. All right. So let me now flip to just a little bit of numbers. As an ex-scientist in my past life, I love numbers. So they will just with those we'll just reiterate on the principles that we listed in the beginning. So here are some examples. So let's take the MariaDB as an example, very popular database service that people run in the cloud. So a benchmark here shows that running the industry standard TPC-C transaction processing benchmark, we get almost 12 times higher throughput and over 7.3 x reduction in the tail latency. And actually, the best visualization for it that I really like is the time series diagram that shows how the two of these databases performance fluctuates in time. So what we can see that Pliops is not only providing much faster speed, but it's also much more predictable. So the spread of the variance of the response times is really small. So it's
and in this environment, the software is a software-defined storage primarily, and Pliops is a Pliops with SSDs. I mean, it's the same configuration, same SSDs, same processor is used, or same server is used.
Oh, absolutely. Yeah, we made sure that the comparison is 100% fair. So we can actually relate that to multiple, technical features that some of them have been listed by Tony. So, for example, our super efficient writes that we perform, we actually do some transformation of random writes to sequential writes, and we manage all that internally. And this is of great help for the database software that uses a lot of random writes, compression, and it's actually a combination of multiple things. So just a sneak peek of how we perform in a reliable dry fault protection configuration with Pliops versus non-protected software with the same number of drives. So as you see, we run here the same TPC-C benchmark over multiple drives, and normally we get something like 250x sustained throughput. And at some point, one of the SSDs in the stripe crashes, and immediately our agent kicks in a recovery process that happens completely in the background and is barely impacting the ongoing database service. So virtually speaking, the clients barely feel the impact of this rebuild process that is going on in the background. We only lose about 10% of the throughput because we obviously use some of the bandwidth of the underlying drives, and we can actually tune the intensity of this rebuild process so that this whole rebuild procedure can happen faster or slower at the expense of the application performance. Bottom line, we can restore 8 terabytes of data with full online rebuild in about 2 hours, even less than 2 hours, and then we get back to the normal mode. So if we want to compare this to an alternative, alternative for that would be a software-defined RAID, of course, and this technology is something that is really recommended against using of by multiple technical blogs and user references due to its prohibitive cost. The reason is that RAID 5, the RAID 5 rebuild algorithm is very intense on read, modify, writes operations. So it's really accessing the drive in a random way, and this is not very SSD friendly, as we all know. So thanks to our internal data organization, we actually reuse the same principle of log structured storage and transforming random writes to sequential writes, and thanks to that, we can actually seamlessly run the recovery and get it complete in less than 2 hours. All right. So last but not least, I would like to talk about cost reduction through QLC adoption, and even beyond the QLC hardware, the more modern hardware types like ZNS. So ZNS is technically even not an SSD. It cannot plug seamlessly into standard file systems. You have to install a specific ZNS-oriented file system for that. So with Pliops, actually, we can operate all of these new hardware types in a transparent way. So getting back to raw performance, we actually played with multiple mixes of read and write traffic, and as we see, the performance gains are 18x to 30x, depending on the traffic blend. Basically, the more writes you have, the more performance gain you can get using Pliops. But it's really a combination of all the features that we provide internally that drives the overall gain. So basically, with QLC and ZNS, we let our customers enjoy all the worlds. It's both ease of integration, so it just, as Tony said, plugs into the software stack as a standard block device, so there is no changes to any software component. We increase the endurance by transforming random writes into sequential writes, and there is a performance boost across a variety of workloads. So this is what happens at the block level. So this is really a micro benchmark, and here's one more example of how we improve the capacity and performance of MongoDB running on QLC hardware. So MongoDB is of course a very popular NoSQL document database, and YCSB is a popular benchmark for NoSQL database systems. So in this setting, we took two drives. One is a QLC drive running under Pliops, and in the other configuration, it's a fast TLC drive, expensive TLC drive running under the normal software stack. So so other than that, no changes have been made. So
Edward,
yes,
the first chart here, I'm trying to read what this says. So it says that you're using QLC and you've got 1/2 the capacity than the customer using TLC.
No, it's just it just says that we perform compression internally. So and in a way that is transparent for the user. So the data itself is 4x compressible, but since this is a database and its storage is actually a blend of data and metadata, the overall space savings are around 3x.
So this is the effective use of the same storage or the same database storage or same database data. How much capacity is actually being consumed on the SSDs?
That's correct.
I got you. Okay, that makes sense.
Right. So thank you for pointing this out, Ray. So yes, and going back to throughput, there are two specific workloads that that we picked: YCSB-A and YCSB-F. The first one is write abundant, and the other one is read, modify, write abundant. And as you see, we got more than 100% improvement in throughput, despite that we are actually using slower storage hardware here. All right, so this gets us actually to the summary. So if we think about what cloud operators get from building their systems around the Pliops processor, it's actually getting the most of all the worlds. Your cloud deployment becomes faster and cheaper because with Pliops you can get decisive improvements in capacity, throughput, and latency. We've seen these gains across very diverse block workloads, block I/O, SQL, and NoSQL databases. The product becomes more reliable thanks to the built-in protection in our card. So where software RAID 5 is prohibitively expensive, we pretty seamlessly replace it in hardware, so the users get it for free. You can run the QLC hardware at the speed of TLC, and the thing I like most about all that it's not a matter of trade-off. It's a matter of getting it all in one. So you got the combination of all of that, and you can build faster, cheaper, and efficient systems. Thank you.
So the technology is really cool, and I see the potential. But actually, if you're focusing on cloud adoption, I mean cloud providers, how many customers can you reach? 20, 40 in the entire world? I mean, it's very. So you're talking about very, very dense servers to take advantage of the card, and numbers are probably not easy to reach for enterprises, for example. Are you also planning a smaller, cheaper version of this card. I don't know how much does it cost actually, but
would you like to take
the idea is
Yeah.
I mean, the idea in general is, I mean, this is very high target.
Right. Well, we absolutely don't want to stop at the cloud. It just so happens that those are the first customers. By the way, the opportunity, the socket size, the opportunity size is massive in the cloud for us. But no, we're absolutely not stopping there. As I mentioned, let's take another Lustre-like example or another distributed file system. We are partnering with vendors that, let's say, specialize in software-defined storage, and this will roll into their environment, and they can roll it, in turn roll it into those enterprise and non-cloud-based IT world. So no, we absolutely are there. Just that the first instances of our deployments are in the cloud, but we're not saying that we're steering away from what you mentioned. And the cost comparison to what we save, comparison to the capacity that we give to the user, comparison to the performance that we give to the user, it washes off. As a matter of fact, when you put our card in, the overall cost of the system goes down. And that's not a cloud statement. That's true for enterprise.
Do you also plan to sell this through server makers, to server vendors?
Yeah, so the way that will work is let's say we partner with an SDC vendor, and then they have an AVL list, and then there's different ones that we qualify with. So we go through the standard server qualifications. It goes back to how server vendors want to distribute it. It's typically might be bundled with a software partner, let's say an SDS partner, but there will come a point where this will be a checkpoint, just like a RAID card is when you go to Dell.com, right? When you put your servers together, that will be a checkpoint down the road for us as well in their configurator system.
Just to make sure that I'm clear with that, since you mentioned it. So if I were going to put a Pliops card in one of my servers, there wouldn't be a RAID card. It would just be, I guess, just a bunch of flash in some sort of backplane that this would control it. There wouldn't be like any sort of RAID card on there.
This could take place of well, if you're putting all flash, a traditional RAID solution is just not it's gonna bring your system down. So, and we love our partners in all domains, and we don't want to upset anybody, but we would say this is the best data protection solution available for servers.
In terms of the hardware that's actually on the card, is it a general purpose CPU that's on there? Or the Xilinx investment suggests to me it's more of customized hardware.
The first go out, so that's the beauty of our structure. If we wanted to just run things on local ARM cores, we would have needed thousands of ARM cores. So that's not the case. We're running the algorithm in gates, in dedicated gates that it's proprietary IP for us. And to answer your second question, yes, the first wave of products is based on FPGAs, just because that's faster time to market for us. And it's also, because we're experimenting new markets, it's easier for us to adjust things. Although at the end of the day, this is the interesting thing. We're finding out that once we add something as a function, we don't have to take anything else away. So it's really one IP that works for many different uses. But we are working on ASIC. We are working on an ASIC to get even bigger numbers out there. So
I can see the early market for the card, but what's the next market to expand into? Because it seems to me that this, like the kinds of efficiency gains that you're going after, you'd need to have a substantial investment in this already. And that's like the hyperscalers, some very, very large enterprises. Where do you see this technology going next?
Eddie, do you want to talk about some of the cool things you're working on and where, if you can, what's the limitations?
So obviously, the edge is a very lucrative market. So for example, all the 5G deployments and cell towers, you know. So in that case, they need pretty much storage that is deployed independently in multiple locations, thousands of locations at the edge. And in this setting, actually, the importance of internal reliability is even bigger, because you know, the whole rebuild process, painful as it is in the cloud, it's very hard to do for when your edge device fails. So this would be a big market for us. Indeed, as you said, you know, it's this is something that is targeted for big deployments, but the number of use cases is beyond just those two that we've mentioned right now. So analytics, not necessarily SQL database analytics, are a very big and lucrative market, and we are going after that. So we just didn't have you know, enough time to share the results there, but you will be definitely seeing that. So the customers might be the same, but the applications are really a broader spectrum than just disaggregated storage and SQL databases.
Can you quantify some of the endurance speed ups or advantages that come with Pliops versus just normal QLC? I mean, I don't know what QLC can do, but it's maybe 100 writes per day or something like that. And with your solution, it could do, I don't know, double that.
So as we said, it's about 90% savings in endurance, and the reason is that well, we actually transform the way the stuff is written. So actually, imagine a random write to an SSD. It's exceptionally painful for QLC hardware. This is something that has to erase the whole page, even if it updates just a couple of bytes in there. So with Pliops, we actually only write the amount of data that has been changed, thanks to our internal structure. So we write less thanks to compression, and we write more efficiently thanks to sequential writes. So overall, the endurance is much less of a headache.
The only thing I would add to that is that, well, I mean, SSD warranties are what they are, and they're typically measured at the worst condition, you know, all writes, all random, all the time. What people are doing is that they're feeling a lot more comfortable with pushing the limits with the drive specs. So we see people are going to 85% drive full with us, instead of, in a typical case, they're putting maybe 60%. So those are the kinds of limits that the customers are feeling more comfortable with.
Do you have any best practice or, you know, test that you have done with Ceph, for example, or any other, you know, software-defined solution for storage?
So let me take that, Tony.
Sure.
So Ceph was actually, it's an interesting system. We actually are working on improving Ceph too, as one of our target platforms. Ceph was initially designed around hard disks. So this was a system that was conceptually for storing media files and things that are not really performance critical or part of any enterprise critical applications. So for that reason, their storage server was not under a huge pressure to be super efficient in terms of performance. So the things have changed as they are moving over to Flash. So they are now in the process of redesigning their internal storage server architecture so that it would be more performant, optimizing the number of threads, memory usage, et cetera, et cetera. It's a pretty big project that is in preview these days. And actually, it's a very good opportunity for us because once the server software becomes faster, then the drives start becoming a bottleneck again. So so in this case, Pliops will become more and more attractive. More specifically, the server metadata service that runs in each backend server for SaaS is the biggest bottleneck of it, and this is something that is very abundant with small reads and small writes of metadata, and in this context, Pliops can be of the biggest value.